Normally I begin a section and just start talking about general chemistry, but this section on solubility, it has many real life applications. I thought I would start with those. So in chemistry 1210, you learned something would be soluble. That was an ionic solid that dissolved or did not dissolve. So you knew that these were soluble ionic compounds, you knew that these were the exceptions. And then there were all these exceptions of things that were insoluble. Well, here in Chem 1220, we are going to learn those compounds have a KSP. You're going to learn how to calculate their solubility and also understand what factors do affect their solubility. Why? Well, there's a lot of real life solubility issues. People have kidney stones. There are sinkholes in Florida. Statues degrade. Your teeth can decay. There's even now the Flint water crisis. The one that I always think about is chelation therapy. That's where you can detoxify something. And I did write people, but that's if someone is contaminated with metal ions, either from the environment or an industrial setting, which is what they did to little children when they had too much lead in their blood in Flint, Michigan. Okay, so here's some pictures. Limestone, it is calcium carbonate. It has a K of approximately 10 to the minus 9, so you know it is not going to dissolve. But in the presence of acid rain, it is going to dissolve. Limestone is also what results in the collapse of ground, say in Florida, where there are sinkholes. It's the concept that we learned about. When we have a solid, it has a lattice, and as you know, if something can surround an ion, that ion will dissolve. Sitting on the bottom is a kidney stone. Kind of ugly, isn't it? It is calcium oxalate, and they said there's been a huge rise in the emergency room of children who have not been having a proper diet, where they really have a lot of salty food. They start to form kidney stones, okay? A big one to me is tooth decay. In our mouths, we have calcium phosphate solid, and when we eat things like chocolate, we tend to dissolve our enamel. Well, if you brush your teeth or have fluorinated water, you will keep that process at bay. So what's the real chemistry? Well, hydroxyapatite, that is the hardest substance in the human body. Sugar will react with bacteria in the mouth and it will form acid. Acid reacts with the tooth enamel, and I hate to say bye-bye enamel, but that is where it goes. So if you drink water that contains fluoride or have a toothpaste with 0.1% fluoride, there is a chemical reaction that occurs that makes the enamel more resistant to attack by acid. That's where my lecture used to stop until the Flint water crisis. I will let you read through the slide, but essentially what happened is the pipe, the lead solid, underwent a redox reaction. It went from lead 0 to lead 2 plus, which put lead into the water. So between 2014 and 2015, I'll kind of walk through this. Lead 2 plus is detrimental in our bloodstream or in our body. Why? It mimics calcium, and what it leads to is cognitive impairment. All right. My son works at a clinic outside of New Haven, Connecticut, and that's where they've seen a lot of kids that have lead in their bloodstream. All right. In lead pipes, A may undergo corrosion. That'll be a chapter coming up. When you properly treat the water, there's what's called a passive lead layer. What you do is you put a phosphate inhibitor in, and that maintains the lead layer, and the lead does not dissolve. But if you have an unprotected pipe, how did this happen? Well, a big city like Detroit added phosphate to their water to keep the mineral layer passive. Flint did not. They quote unquote saved $50,000. Well, when that happened, the pH dropped, and when it dropped, they formed more lead compounds that were soluble, and you will learn that weak acid anions react with acid. So that's where the lead came from. There was another issue. There were high levels of chloride ion, and while lead chloride that you made back in 1210 is fairly insoluble, other compounds of lead formed which were very soluble. So all of this has to do with the chemistry we're going to teach about in this section of the chapter. I find it pretty interesting because there are real life applications.